Hello and welcome to a new video with machine learning in Python. I was quite busy doing other tutorials in the last couple of months, but from time to time I like to create some interesting walkthroughs in the field of machine learning. And this is geared towards beginner to intermediate level programmers. Okay, today we are going to create a model for heart disease prediction using logistic regression. And let me start by stating an interesting fact from the World Health Organization. They have estimated that 4 out of 5 cardiovascular disease deaths are due to heart attacks. So, in this machine learning project, we are going to check out the ratio of patients that stand a good chance of being attacked by CVD, and also to predict the overall risk. And logistic regression is a combination between statistical and machine learning techniques classifying records of a data set based on the value of the input fields. And its sole purpose is to predict a dependent variable based on one or more set of independent variables to predict the outcomes. So I have here a data set which is available on Kaggle website, and it's from a cardiovascular study of the residents of Massachusetts. And the classification goal is to predict whether the patient has 10 years risk of future coronary heart disease. And I will refer to coronary heart disease by CHD just for short in this video. So this dataset is in CSV format, and it provides information about patients including 4,000 records and 15 attributes, as I will show you in a second. So first of all, let's go ahead and create a folder, and I will call it CHD_ML. And I'll open that by Visual Studio Code, but you're free to use not only IDE, but you can use Anaconda, you can use Google Colab. These websites will allow you to use Python without installing it on your machine. Okay, so this is the CHD dataset. You have gender, age, education, and so on. We will use also some attributes like cigars per day, diabetes level, glucose, total cholesterol, okay, and the 10-year CHD. This is very important in our study. Okay, let's close that and let me create main.py. So I'm going to import some libraries now. And the confusion matrix, we will use it to find the model accuracy by the end of this tutorial. Also, I want to import Seaborn, which is a data visualization library. It's based on matplotlib, by the way. Also, I want to import matplotlib.lab, mlab, give it an alias of mlab. I want the pre-processing package, so from sklearn. And this is for normalization of the data set later. I want to import statsmodel.api as sm, give it an alias. So py.optimize, okay. NumPy, pylab, pandas, Alright, so these are the packages that I need, and I know they're quite a lot, but we will need all of that in our project. Okay, so make sure you type that correctly, and let's continue. So first of all, we have our dataset in the same directory, so we will need to read the dataset. To do that, let me create a variable. We'll call it CHD data. This will be equal to pandas.read CSV, and I will pass inside the name of the file, Massachusetts.csv. Alright, in the dataset there is a column called education, and I want to drop it. Okay, so let's do it. So CHD data dot drop, and I want to drop education, set in place to true, and also access to 1. And this should be inside brackets like that. Next thing that I want to do is I want to remove all the NaN or not a number. So removing NaN. So to do that, we will take our CHD data and we'll use drop NA method. And in place equal to true as well. And I will print the head of the CHD data. So CHD dot head. Okay. And CHD data dot shape. Okay. Also, we will need the data itself, so we want by 10-year CHD dot value counts, and we are good to go. So let's actually try that out. That's the terminal. I made a typo here. Pie plot, not pile plot. Let's try again. Okay, so we have the first 5, so from 0 to 4. 5 rows, 15 columns, and we have dropped the education. So you have male, age, current smoker, and this data set represents only men. There are no women included in the study, just men. Because statistically speaking, they are the most exposed to have CHD than women. Okay, and other attributes. So 10-year CHD, D-type, so we want to, this is our interest actually, the 10-year CHD, okay, to calculate the risk. All right, let's get back. Let's close it, okay. Next, what I want to do is I want to count the number of patients affected with CHD. So counting number of patients. Okay, so take the PLT, which is the pie plot. Where is it? Which is here. Dot figure, and give it figure size of let's make it 7. Let's make it 8.6. Okay, height and width, and I will use the Seaborn module to count plot. So on the x-axis I will write 10-year CHD. The data is taken from our CHD data, and palette argument all right, and finally we'll show that. So plt.show, oops, like this. So let's try that out. Okay, showed on the other screen. So here 0 is the number of affected and 1 is being the number of unaffected by the CHD. Okay. Yeah, so this is the count from 0 to 3000 according to the 4000 records inside our CSV file. Okay, let's shut that for the moment. Let's close terminal. The next thing that I want to do is I want to train and test the sets. So I will split the data and I will normalize the data set. So let's create X and Y variables. We'll take NP dot AS array, here our CHD data, and I will select some attributes from the head of the CSV file or of the data set. So I will only take age, male, how was it called, cigars per day. This, I will take this, I will copy that here. I also want to take total cholesterol. I will take that. Okay. And let's take glucose. And that's enough. That's okay. On the y-axis, I want to arrange or sort the array in a manner that it shows the 10-year CHD. So CHD data, and here 10-year CHD, like that. Okay, so here's our x and y variables. So here let me add a comment, and let's actually close that and make it big. So here I will add a comment. I will say train and test data sets, or just sets, to not confuse you. Next, I want to normalize the data set, okay, which will work only for the x-axis. So here, normalize the data set. So what I will do is I will use the pre-processing package that we have imported above, dot standard scalar method, and this will be followed by fit, and I will pass x, and also transform method, and I will pass x. Okay, so this is basically it. These are the three main lines in order to allow me to train and test the sets. So let's actually train and test x and y sets. Alright, so let's declare several variables: x train, x test, and also I need y train, not train, but train, and y test. And all of that will be equal to the main method here, train test split. So train underscore test split, okay? And what I will pass, well, I will pass the x and y variables or sets. And I want the test size to be equal to 0.3, and the random state, random without e, state, equal to 4. All right, cool. Let's actually print the train set and the test set. So train set, side single or double quotes. Okay. For some reason I like single quotes better than double quotes. I don't know why. So we will take the x train shape and the y train shape as well. Okay. And the same thing, but instead of train, now I need the test set. So instead of train, I will type test. Okay, x test and y test. Give them some shapes. And let's actually try that. Let's print this and see what we'll have. So we have train set and test set. Okay, 2625 with 5 and 2625. And the test is 1126 with 5 and 1126. Okay, so we have successfully splitted the train and the test sets. All right, this was the whole goal of this. All right, let's shut that and let's maximize again. The next thing we want to do is we want to model the data set. So modeling the data set. data set. Okay, and this is for evaluation and accuracy. And here we're going to use the Jaccard similarity coefficient, or Jaccard index sometimes in statistics. And also it's called the Jaccard score. And simply what it is, it's a statistic used to estimate the similarity and diversity of sample sets. So it sees the intersection between two shapes. So if just let me show you real quick in statistics how it's done. So let's say, for instance, that let's say that we have one rectangle, and this is rectangle A, and let's have a second rectangle, and this is rectangle B. This union between both rectangles, or this intersection, okay, this is one part, okay, this is the union between both rectangles. So the Jaccard in statistics, the Jaccard coefficient, is calculated by taking this part, this union, and dividing it by the total shape of the intersection. So this is how we get the accuracy between two different sets in this case. Both rectangles represents different sets. And if you will see now in machine learning, when a camera tries to detect pictures, for example, and you see sometimes, often you can see, let me just make it so it will be clear. Let's say there is a picture and you will find that it's in green, and another one around it, I'm sorry for that, in green like this, and another one, let's say in red, and around the picture. So this determines the accuracy of the image, or this picture captured. And as I told you, they take, or technically speaking, what they do is they take this this area right here, the union between both shapes, and they divide it by the total shape of the intersection between both shapes, and they get a number. The higher this number, the more accurate is the prediction, and the less the number, the less accurate is the prediction. So this is how it's done. So what I want to do now is I want to create an object for logistic regression module or package. So we'll create or declare a variable, we'll call it log reg, and this will be equal to the logistic regression module. And I will take that module and I want to fit inside the X train and the Y train. And to predict the Y set, I want to take the log reg, and I will use predict method, and I will pass inside the X test. And now I want to check the evaluation and the accuracy. Okay, and I will concatenate that with the score, and I will get inside or pass inside the Y test and the Y prediction, and this is Y underscore test. Okay, perfect. Let's go ahead and try that. You need always to test your code. So sometimes I forget and I continue to write code and it creates this snowball, and I don't know where is the error exactly. Sometimes the error report is not as helpful as it should be, and that's why I always recommend that you test always your code. So let's just hit up on your terminal to bring the last command that you've typed. Okay, so the accuracy of the model in Jaccard score is 0.05454545. All right, so this is the accuracy level. Okay, let's close that actually. So the last thing we want to do in this project is we want to use the confusion matrix to find the accuracy of the model. Okay, so let me add a comment here, confusion matrix. And the confusion matrix actually is just a table that describes the performance of a classifier or classification model. Okay, so let's go ahead and create confusion matrix variable. Okay, also I will need to pass inside the y-test and the y-pred. And I'll declare a second variable. I will call it cm setup. And here I will use pandas dot data frame f capital. And what do we want? Well, we want the actual data, which is stored in the cm variable. And we want columns and indexes. So columns will be equal to, and inside the list, I'll say predicted is 0. It's just the guidance, okay? And predicted here is 1. And the index will be equal to also another list, actual 0 and actual 1. Oops. Okay. Fine, and let's use PLT figure. Okay, let's give it 9 and 6. Okay, this is just the size of the figure like we did above. And we want the seaborn again to heat map, and inside the heat map method I want this setup to get inside. Okay, this only configuration for the graph, nothing more. Annotation. Okay, CMap, it's greens like this. And why greens? Because in the graph we'll have different tones of green color. Okay, so that's why. And it should be in G like that, otherwise you will have a big error. And let's go ahead and show that. So save. Let's open the terminal. Let's actually close off all that. You see, when I did blue before, it gave me this bigger. Okay, Python main.py. Just hit on the up arrow to bring the last command in your terminal. Alright, so we got this graph as before, 0 and 1, affected and not affected. And here is our confusion matrix report, okay, or confusion matrix graph. So you have predicted 0, predicted 1, predicted for the affected, and predicted for the not affected, and actual for not affected and actual for affected. All right, so this is the intersection between the predicted and the actual. So this is the whole point of the Jaggers coefficient or the Jaggers score. All right, just to show the intersection between the actual and the prediction. Also, sometimes companies do this kind of study in the budgets. When the company in the beginning of the fiscal year, they start to prepare for the budget, and sometimes the companies or the companies that heavily depending on sales, they do these types of studies. They actually put actual sales and predicted sales together and see what's going on. All right, so let's close that. The last thing, let's close that. Last thing that I want to do is I want to show you the classification report. So let's close this one. Only 2 lines remaining, so we will print details for confusion matrix is okay, and the actual report, so it's classification report, And also I want the Y test and the Y prediction pred. Okay, let's run that one more time and one last time. Okay, we have the same graphs, we have all that because I didn't comment the previous commands out. The details for the confusion matrices. So we have precision, recall, F1 score, and support. Okay, so I have 0 for affected and 1 for not affected by the CHD. Okay, to have coronary heart disease. All right, and this is the precision level. So 0.85 and 0.89. Okay, you get other measures such as the macro average, the weighted average, okay, the accuracy level on the F1 score. All right, so this is it, guys. I hope this video was helpful to you. Even if you have learned a few things from it, it's very good to take that and go ahead on the Kaggle website and check out other data sets and try to replicate that, but using other data set. Let's say for sales, for example, and try to play with the code using different data sets. This is how you will learn. So thank you very much, guys. I hope you liked the video, and I will see you in the next videos. Take care.